Hello, so in this video we're going to start talking about arrays. Now if you remember in the last video we were talking about matrices. Now if you remember, a matrix was just like a two-dimensional version of a vector. You know, a vector is just a list of numbers. A matrix is kind of like stacking those vectors on top of each other to form a table. Well, an array then is a bit like taking a matrix and then stacking those matrices on top of each other. So basically form like a three-dimensional matrix. Okay, that becomes an array. And actually you don't need to just be restricted with an array to 3 dimensions. You can have as many dimensions as you like, but you can't obviously visualize those. But hopefully by the end of this video you'll have a clearer idea of what an array is. So first of all, let's start by building an array. Now in order to build an array we need some matrices, and in order to need some matrices we need some vectors to stick into our matrix. So first of all, I'm going to do it with two matrices. Let's first of all start by building a vector. I'm going to call it v1. Okay, and it's just going to be the numbers from 1 to 12, just like we were doing in the last video. Okay, and then I'm going to say, well, my first matrix then is a matrix from the data v1. Okay, I'm going to have the same number of rows, which is 3. So n row equals 3. Oops, n row equals 3. Okay, and I'm going to have the same number of columns. So n col equals 4. And I'm going to fill it by row. So by row equals true. And that, remember, goes 1, 2, 3, 4, then it starts the next row, 5, 6, 7, 8, then 9, 10, 11, 12 in the third row. Okay, cool. And then my second vector is going to be v2, and it's going to be all the numbers from 13 to 24, so 13 to 24. And I'm going to build a matrix, m2 from this, which is just a matrix using the data in v2. Again, same number of rows, so number of rows equals 3, and number of columns equals 4. Okay, and again I'm going to fill this by row, so by row equals true. Okay, cool. Now I'm in a position, now I've got my two matrices, to build an array, and I'm just going to build an array from taking m1 and then stacking m2 directly on top of that. So I'm going to call my array A. I can call it anything I like. I'm just going to call it an array. And again, there's a function in R which builds an array for me. So I'm going to tell R I want to build an array, and that's just the array function. Open up my function brackets, my function parentheses. Okay, and first things first, I need to tell R what two matrices I'm going to use to build the array from. Now, I do it by forming a vector because, of course, you could have as many many different matrices stacked on top of each other. So I'm just going to build it from saying a vector of m1 and m2. So it's just going to create basically like a list, m1, then m2. If I did m2, then m1, then m2 would come first, and I'm going to stack m1 on top of that. But I'm not. I'm going to do m1 first, and I'm going to stack m2 on top of this. Right, comma. Now I need to define the dimensions. Now, the thing is with the dimensions, you know, I can't just define number of rows equals 3 and number of columns equals 4, and then kind of number of z-axis is equal to however many, because of course it could be a multi-dimensional array, okay, which then means that I'd have to then try and come up with different names for like the 4th dimension, the 5th dimension, the 6th dimension. It just gets really difficult to understand. So the way we should do it is just by defining a vector. So I'm going to say dimensions, dim, or dim, just equal to, and again I'm going to write a vector, okay, and it's going to be, first of all, the number of rows which I've got, which is 3, then the number of columns which I've got, which is 4, and then I'm into my third dimension. How many matrices have I got? I've got 2. Okay, fine, and that should be enough for the time being. So if I click source, now obviously I can't view this matrix all at once, okay, because I've got a 2-dimensional screen and I can't really view it in 3 dimensions. But you've got to imagine this is like a cube or a cuboid, okay, where I've got first matrix stacked on top of my second matrix. So what I can do then is I can access certain levels of my array. So first of all, if I want to access the first level of my array, that's my first matrix, all I do is I'm not interested about the rows, I just want all the rows, I want all the columns. So I've just used a couple of commas. Then the third entry, which I'm going to put in, is the matrix which I want to access. So I want to access the first matrix, press that, and there you go. And there I've got my first matrix set up there. Okay, likewise, if I change that to the 2, then it accesses the second matrix. Okay, so the second level, if you like. And there you go, that's the numbers from 13 to 24. Okay, cool. So I guess, why is this useful? Well, you could be, for example, in a doctor's surgery, right? And you have all this information about your patients. So your first matrix is all the information about your patients for 1 year. Then your second matrix is all the same information about the same patients for the second year. Okay, so obviously you want those two things stored together, right, in an array, and you can just access the different levels for whatever year you want to access. In fact, let's do that. Okay, let's suppose we have 3 people, so each row corresponds to a different person. So let's say, let's just create a vector for names. Okay, and these are going to be the different people that we're going to have. So I'm going to use text, so I'm going to use the quotation marks, and let's suppose our first person is called Kim, let's suppose our second person is called Kanye, and let's suppose that our third person is called North. Okay, so these are each of the rows. Okay, now let's suppose that each column is the different information that we've got on each person. So let's suppose we're in a doctor's surgery. We're going to call it info. Let's suppose that the first column corresponds to height. Oops, height. So the height of each person. The second column corresponds to weight, right? And the third column corresponds to shoe size. And let's suppose that the fourth column corresponds to hair length. I don't know. Hair length. Okay, cool. Right. Now what I can do is if I come over to my array, I can specify the dimension names. Okay, so I put another comment in and I use dim names. Okay, equals, and then I create a list. Okay, so dim name just seems the dimension names of my matrix. The list, open up my brackets, and I'm just going to list these 2 vectors. So the first vector is is my rows. The second vector is my columns. So this is info, and I could put a third one in to say which year it is, but I kind of know what that is anyway. Okay, so press source. Okay, now if I access the third level of the the first level of the array, so comma 1. Okay, you can see now that I've got all the information for Kim, all the information for Kanye, all the information for North for the first year. And then, for example, if I just get rid of that before it goes off the screen. Okay, now, for example, if I access the second level, so comma 2, okay, I've got all the information for Kim, Kanye, North for the second year. Okay, and then I can pull out specific people. So, for example, I might want to pull out all the information for Kim for the first year. So Kim is the first row, so I type the first row in the row bit of my square brackets, and I want it for the first year, so I type it in the year bit, which is the level, and then you can see that I've got all the information for Kim, okay, and I can do exactly the same thing for her for the second year. Okay, so I can see how her information changes for the second year, and I can do it for anything. So, for example, I might want to see for the first year all the different heights which I've got, which is the first column. So I type that. Okay, and then you can see that I've got all the heights for Kim, Kanye, North. Then I do the same thing, but this time for the second year. Okay, and then you can see how Kim, Kanye's, and North's heights have changed for the second year. So I can do all sorts of things like this. So arrays, really, really useful if you want to stack matrices on top of each other. I've just done it with a 3-dimensional example, but if your brain can handle it, you can go into higher dimensions.